Hello, everyone. My name is Ray. Yeah.
Hello, I'm Ankit.
So we are from StubHub. So we are both working for search. So we are search engineers. So we want to present something we did in our real use case for bootstrapping learning to rank for our suggestions. So before we start the topic, I want to introduce about our company because probably most of people was not familiar with StubHub. So StubHub is a secondary ticket. It's a ticket marketplace. So here are some numbers. So we are the leader of ticket marketplace. So our goal is to try to connect fans so that fans can go to events they want, and so there are no sold out ticket in StubHub. Yeah. So there are some numbers, and we are also worldwide company. We are international company. We have across 44 countries. We have our site and tickets. Yeah. So about our business, so it's very simple. For example, we are marketplace, right? So we have a seller. They have tickets. Either they are ticket. There might be a season ticket holder, or they get some tickets. They cannot go to the event, so they will resell that ticket in our platform, so that we will connect the buyer to seller, and then we make the buyer happy, seller happy. Yeah, everyone will be happy. Yeah. Okay. Yeah, this is our agenda. So first, I will go through how we are going to do search at StubHub, and we do have some challenges with suggestions, and the other one will be Ankit will be introduced how do we solve this by machine learning and learning to rank. Yeah, so first I want to introduce several pages from StubHub UI. You can see this is for search result page. It's pretty common, for example, like Google, right? You type some keyword, you hit enter, then you see the result. The only difference is that StubHub, because our focus is event, so most of people, they want to find the event they want to go to, then they can decide which ticket to buy and purchase. And you can see we have some matches, then we have keyword, then you can see we have top matches, means that this is the most popular one for this keyword, and you can click on that, then you navigate to the, we call the performer page. So you can navigate to San Francisco Giants or New York Giants or whatever Giants. Yeah. And also the key part for StubHub is this one. So when you land onto StubHub, right, you have a search bar. When you type something, you automatically get something. In StubHub, we internally call suggestions. It's a quick link so that you can either go to the performer or go to the event. Then you can pick your ticket, then you can begin your purchase. Yeah, and this is a major use case for StubHub, but StubHub have been using Solr for more than 10 years. So Solr empowers StubHub a lot. So we have lots of features depending on that. So this is, we call the catalog search. So we have our whole catalog system powered by Solr. Then we have suggestion and performer page and search result page all by the Solr. We do the query, ranking, and maybe boosting and query elevation and re-ranking there. Also, if you go to StubHub, so if you go to the click one of the event, you will see all the tickets. That's also powered by Solr, because we have, I think we have more than maybe 4 million tickets across 100,000 events. So we use Solr to store all the listings so that to reduce the overload to DB, because before we use that, our DB crashes a lot every day. Even we switch to read-only DB, the read-only DB cannot afford that traffic. But when we switch to Solr, it's definitely handled that. Yeah. And yeah, that's my, yeah. The next one is about, as I mentioned, the suggestion API. The suggestion is a major heavy one for StubHub. There are some numbers. So the peak number, it's about 60,000 per minute. So that because we have CDN to help us to offload a lot of traffic. Otherwise, it will be more than that. So we use Ackman heavily to reduce that traffic. Yeah, and also it will be 30% of the most start point for any user. They will go to first. They will already enter something, then click start from there. And we have, because you know it's a suggestion, right? So we have very limited result to show. We only have top 3 results to show. So we hardly depend on our ranking mechanism. For example, we have multiple factors. Proximity definitely is the first one. This time means the event time. So if an event is going to happen soon, next week, tomorrow, it will definitely be ranking higher. And this is price is mean that so if the event have some best deal or some good price ticket, also this one will rank higher. Trending means that so lots of people are looking for this event, have lots of page click or sales. This is called trending. And the result from previous match means that there are lots of hit or result match for this keyword. Also we will consider that and also take it a variable. And also active events mean that when you find a performer, if have maybe 100 events available, then it will definitely be ranking higher than the performer is only have maybe two events available. Yeah, so I call the legacy suggestion because we already solved this problem. So currently our site is not running this version. This is the old one. The old one is the problem several issues. First one, top one is that we're ranking based on single dimension because before we using machine learning and learning to rank, so we depend on Solr to do sorting. So everyone know when you do sorting, maybe you can only sort by some parameter, right? The first one always win. So if you sort by our single dimension is about sales. So we assume the event or the performer have most sales will be most popular one for us. And then it works perfectly maybe for, I have to see maybe 70%, maybe, but there are some problem. For example, if some event, for example, Super Bowl is pretty high, the sales pretty high, then they always rank on top. The other event have no chance to show unless that event finished. And also, that results the low click-through rate because maybe people are looking for some different thing, but they cannot find that, then they give up. Yep. And also definitely some complaint from business and user because we get tons of requests. For example, they ask me why this keyword I type in, why you show me this one instead of another one. So I remember because the peak season, for example, MLB or World Series and NBA Finals, I get lots of requests, boosting requests for some keyword. They want to show some specific result, which is we cannot boost because the reason is that the event just start. There are no sales on that yet. Yeah, this is another issue. Yeah. And also, as I mentioned, so we ignore all the other important signals because when you're using sort, then the first one always win, right? Only when they tie, the second sort will be effect. Yeah. Yeah, you can see the last one is artificially boosting by Delta and product team. So yeah, we originally we have a lot of issues. Then someone asks us pre-boost that. So we keep doing that. You know, manually boost is okay, but you have to know you need to clean up. I still remember one good example is for Final Four. Final Four is pretty popular here. It's NCAA event, right? But after that finish, I forgot to remove the boost. Then we have a Europe team. Europe also have Final Four. It's also not basketball. So then they have issues, they complain, then I feel it's become another problem, which means that I try to use business rule to solve all the ranking problem. This is definitely not good. Yeah. So now I will hand over to Ankit for the solutions.
So about the solution, any guesses? Yeah, machine learning. So basically, yeah. So all this kind of problem, can be solved by machine learning. Yeah, machine learning will optimally rank it, but then with machine learning, you need training data, right? So the problem is now when we have clicks for the performers with high sales, when we train a machine learning model, we'll get a model that predicts performer with high sales on the top because garbage in, garbage out. That is the problem with the machine learning when we don't have good training data. And other thing is, how do we start then? Because we just have 3 candidates in the suggestions to click on, right? So the low sales performers will not get a chance to come up in the ranking. So this is a cold start problem. When you don't have good training data, you cannot have good model. Then how do we solve it? So yeah, talking about training data. Usually for machine learning purpose, training data is seeded by graders. So graders are manual people who will rate the results. And depending on the results, you can train your training data and you can use a machine learning model. Now with StubHub, we have like 3 broad categories. For example, sports. In sports, we have NFL, MLB, NHL. So a person might be, fan of 1 or 2 categories. Then we have concerts. We have concerts, theater, right? So if we need graders, right, we need to, sample graders equally from all these sections, and also depending on the location. For example, giants might mean different in New York, in UK, and in San Francisco. So that is a problem. So we need kind of, good data for that, and which is challenging to get it from the graders too. And it is also difficult to mock user expectation, because with time, the demand for different entities change. With the season, the demand for different performance change. So it is very difficult to use graders to do this job. And I guess this is also very expensive, because you have to handle the logistics and pay different people. And yeah, the calendars change, right? The event that or performer that might be relevant today might not be tomorrow, because outcomes of the games, or if the season expires, or if new season is announced, new tour is announced, the demand for performer would be totally different, right? And as I said, expectation change with time and location. And for example, giants might mean like 4 different performers depending on the location and time. Now, bootstrapping. How do we bootstrap? We don't have training data, and we want to use machine learning. Now, I think that is the biggest problem that I've seen. I've spoken to many people around here, and that is the problem. So thing is, like, even you must have seen in the keynote, start small, and then you can use complicated ways. But how do you start small? That is a key part, that like most of the people, you won't explain you. Start small with a simplest model, like, linear regression. Now, in the days of, neural networks and deep learning, people might, warn you against not using linear regression and stuff. But I would say use it so, because, you can look at the weights and you can say something about the model. You can interpret the model. And also when we use linear regression, we didn't train it actually. We manually tweak this weights. And how do we do it? I'll explain you. So let's see. In this slide, we have 3 performers, performer 1, 2, 3, and we have 2 dimensions. One is distance, another one is popularity. And distance has some weight, let's say 0.6, and popularity has 0.4. So performer 1 has distance score of 0.7. That means performer 1 is close to the user. Performer 2 and 3, they are far away from the user. And in terms of popularity, performer 1 is least popular, performer 2 is kind of popular, and performer 3 is very popular. Now, how do we rank these 3 performers based on the data we have? So what do you think among these performers, which one should be ranked on the top? For StubHub, the one which is closest, that should be on the top. And a faraway performer, that is kind of popular. Let's say if you have Super Bowl that is far away, people would still pay for it to fly there and attend that event. And there is a faraway performer, right, who is not as popular, then we don't care about it. So if you use the formula and substitute these values, and as you see the formula, if you have seen the linear regression, multivariate linear regression formula, it is the same formula, just that we have dropped the constant weight. So by dropping that, the actual score might go beyond 1. So that is fine, because we are ranking it absolutely. So we see for the performer 1, the score is 0.5, for performer 2 is 0.46, and for performer 3, it is 0.58, right? So if we rank by those, the performer 3, which is far away but popular, will be on the top, followed by performer 1, followed by performer 2. So if we see any deviation from the expectation, we can easily change the weight 0.6 and 0.4 to suit our purpose, and then we can play around and change the behavior. Now, the behavior, to change the behavior, it is difficult with like 8 parameters, but depending and observing the user complaints from the business, and observing the data in the production, we can tweak weights for all these factors. So we have lexical features and non-lexical features. Lexical features are like exact, prefix, fuzzy, term match, and also alias match. For example, Oakland Athletics might have Oakland A's as an alias. San Francisco Giants might have SF Giants, and so on. So we store those alias, and we also use their match also. And also, we use distance from the user. Sales for last 14, again, sales is important criteria, as we've seen. Sales for last 1 day, if there is anything that is picking up sales. Type of entity, is it like performer, grouping, or category? And also the active events. So scaling features. Even when we use linear regression, we scale the features so that the value is between 0 and 1. And there are a few binary features like exact match, if it is an exact match or not. prefix match or not, alias match or not. And distance and sales, we use logarithmic transformation to scale these two signals between 0 and 1. Now, by doing so, what we are trying to do is, we build a feature set that can use either heuristics and can also use machine learning. So we are not just, it's not a throwaway work, right? You're building a platform so that you can use your machine learning on it. So tuning weight. Now, as we've seen in the previous example, we heuristically tune this individual weight based on the golden set and the stuff we see. And we keep tuning this. Like even when we release it in production, when we got like complaints from the business, we tune this weight so that we have the optimal ranking, and we can actually observe the one, if there is an issue, like XYZ performer is not being shown, you can look at the features during that time, and you can tune the weight. So it is far more intuitive than any other machine learning methods. And it improved over the baseline ranking. And it is very quick, very fast, efficient way to roll out machine learning and learning to rank. And this improved click-through rate can give us data that we can use to bootstrap a machine learning model. Now your problem is solved. You will have the training data that you can use for ranking and serves as a checkpoint. Let's say for any other reasons, like you decide not to go and implement the proper machine learning way to do it. Even if you leave it at this point, it will still work. Basically, you'll have to still tune the weight here and there occasionally. Now we use a two-pass approach. So when a user types in a query, it goes to a microservice. The microservice fetches a bunch of data. Like for example, GI is the query. We fetch all the data that starts with or contains GI in it, Young the Giant Marco and stuff. We have like 50 plus performers, let's say. And then we fetch this data in the microservice. And in the microservice, we do a fine-tune ranking based on machine learning model. And we pick the top 2 or 3 performers, and then we return the results. Now, there might be questions around why do you do that? Why do you not leverage the Solr ranking or Solr LTR plugin to do this, right? Now, because there are features that we need like constant updates. For example, sales or views, which are constantly updating, right? We cannot update it so frequently with Solr because we'll be having high read traffic. And the problem occurs when there is a high read traffic, and when you're also updating, basically it will cause memory issues. Another thing is it decouples you from Solr, and you can use other methods supported other than the one supported in Solr. So yeah, this is again the explanation of the two passes approach. Like it is expensive to update the Solr, the features in Solr, and you are flexible basically to leverage ranking outside Solr. And this is the result with just linear regression with heuristic weights. We observed a 21.9% increase in the click-through rate for the first performer, right? So yeah, that was really unexpected, but it worked really well for us. Now coming to the machine learning with learning to rank. So we have the training data that we obtained from the click-through positions. We'll be using the pairwise approach to compare the ranking. And since we are doing it on the API side, I think we used Vika, but probably we'll switch to other methods going in future. And we use the same features used from the linear regression. The features are already there, and use the same two-pass ranking. So nothing changes. Here, just the model changes, and you can switch and A/B test between the models. So now this is the pairwise ranking. For example, we have these 3 performers, and it has certain features. And that is the predicted probability. If the user clicks the second result, we say the probability of its click is 1, while others have 0. And we gather this data, and using tracking and all, we gather this data, and our final training set looks something like this. That has the values of all the features, and has target the probability of it being clicked or not as 0 and 1. And then we tune a neural network model, and the value of our hyperparameters after trying different hyperparameters, the learning rate is 0.1, momentum 0.4, and so on. And yeah, this can be different based on different data, and we also with time we need to keep on tuning it. And this is our final NN neural network model configuration that we used to obtain the ranking. So these are the few examples how we are ranking based on this model. You type in if your location is San Francisco, and you type in San, you'll be seeing giants, San Francisco giants. If you're in San Antonio, Texas, if you type in SAN, you'll see San Antonio Spurs. And if you're in Los Angeles, if you type in San, you'll see San Diego Padres. So it handles these cases very well. And in these examples, I was able only to demonstrate change in one dimension, that is location, but also with time, when things change, you'll see different result. And yeah, these are the final results. So our method of measuring our success is how many % of the user clicked on the first result. So it is very simple method to explain to the leadership and to understand, have a common terminology. So 14-day sales was just 51.5, linear regression 73.4, and with neural networks is 82.3. And I think with few modifications, adding eight number of features are kind of less, but we are trying to add more features. And I think we can get to around 90% with our newer models. And enhancement, yeah, as I said, we'll be using StubHub machine learning platform, which has kind of the feature stores, and will be using different models and integrate with more real-time features and add like features that will make our model robust, that our model won't decay or decay very less with time, and adopt the same mechanism for ranking the events and the venues, and also the search result page. Yeah, so this is our team. Here's Charles, our engineering manager, Ray, myself, Fazil, our product manager, Akhilesh and Soren, they are software engineers with us. So thank you. Any questions?
So you mentioned that you have two search going to find the final results. How do you do the two search? Do you get the first search results and then you send it back again to Solr?
Okay, so we fire like a couple of queries. One is by distance and one is by keyword match, right? So when we get the results from both the queries, we rank it in the Solr, in the API, and then we send it back to the user. Does that answer your question? Which two queries are you talking about? Can you explain?
Yeah, the two queries. Do you run the second query as a component, as part of the search results, or?
So we make it simple. So we run two queries asynchronously. So we parallel call and get both results. Then we do ranking and rescoring in our microservice. Yeah, but we can do that. Yeah, we can do that also. Yeah, we can use the search component, can return two sets of results in one response maybe. Yeah.
I see you are suggesting as you're typing, it's just like automatic suggestion.
Yeah.
So for each keystroke, you are executing this query and returning the results in microservice and returning the results. Do you see any latency by implementing this machine learning?
So with machine learning, I think it takes like less than 10, for the machine learning component itself, it takes less than 10 milliseconds. So I think, so the evaluation part, when we try to evaluate anything with machine learning, it is very fast. I think only the training part and stuff, that is very expensive because we have a lot of data and we have a function to estimate. The evaluation part is pretty fast.
So, sorry. Regarding your question, so there be some performance degradation. So we do saw that because our previous one is sorting by some one popularity or something pretty fast because just one Solr query return that result, right? But when we introduce the model, because we have one more query, then we have extra work. So I think add maybe about 50 milliseconds. But previously is about maybe 150 milliseconds. Yeah.
So. Yeah, so it is just 150 millisecond, the total entire. Yeah, I think it is like within our SLA. First thing is within our SLA, and as I said, there is just 10 millisecond latency increase for evaluation, but for the query part, since we are firing two queries right now, there is the increase in delay.
Okay, I think you forgot.
Yeah.
Did you have any issues of not returning any results because you filtered many of the results based on machine learning algorithm?
Yeah, so we like, we fetch a fixed number of results in the microservice, like 100 number of results, and then we rank it. We don't kind of filter it in microservice. We just rank those. No, we don't filter it. We just rank it. Yeah.
So this is an interesting approach to this distance, or maybe I misunderstood. Solr also has a location functionality. Like if you store the location of the theme and you pass it, the user's location, Solr can tell you the geographic distance. Are you guys using that?
Yeah, we are using that.
So we use distance, yeah, definitely. We don't rank by distance, but when we get the performer results, we also have the distance field, and we can use that as a feature for ranking.
Solr gives you that distance.
Yeah, yeah.
So you tied in pairwise ranking, is that right?
Yeah.
And is that going over only the Greek results? Or do you look some outside the initial ones and why pairwise instead of looking from the lists?
Yeah, so since this is like bootstrapping beginning, I think the pairwise is a simpler approach, right? When you see, like, you can take any two results, one which is clicked and other that is not clicked. And I think listwise would make sense if there are a number of results, and I think listwise is more sophisticated way. And I think we might use listwise for search result page rather than suggestions, which has limited number of results. All right. Thank you so much. Let us know about your feedback or any comments and criticism.